We're going to work on the left side again. So here we've got cosecant, which we know we're going to want to change that into sine or cosine. So this is sine. Let's write it like this, a little bit lower. So now what we've got is on the bottom, we're going to use our formula for that double angle for sine. So let's go ahead and grab that. Tells us that this is equal to 2 sine theta times cosine theta. And now this denominator, I can write it like this. So I just want everyone to be very clear on what I'm doing here. I'm taking and putting 2 more 1s up top, like that. I haven't changed anything because it's still 1 up there. Now what I'm doing is I'm basically reversing the multiplication process. So instead of sticking them all together, because essentially this over here is what this is. So this gives me 1/2. 1 over sine is cosecant, and 1 over cosine is secant. And that's it. Now if you want to write it out like they have up there, you can. That looks like a smiley face. I don't know why I found that amusing. Okay, so we've got this. I have secant of smiley face and cosecant of theta. Now this is theta too as well. Okay, now I can switch the order here to here like I did down here by using the fact that multiplication is commutative. So the commutative property of multiplication works with real numbers, and these guys, their outputs are real numbers. So the only time we can't do this, the only time this guy's not going to work is when 2 theta gives me a sine value of 0. So if we're, I don't know, at a situation at like 0 degrees, 2 theta would do that. At pi over 2 degrees, this thing's not, you can't go ahead and get a solution out here because it's not defined. Okay, but otherwise everywhere else you'll have solutions. Okay, and we can go ahead and use this, and this identity is going to hold true.